Hi everyone,
In
we're
this
reaching
lecture,
out to
I'm gonna
second
quickly
part, which is about
provide an
normalization.
overview of the normalization process. Again, something that you have reviewed in your database course. But basically, normalization refers to the process of assigning attributes to the entities, and overall, the key reasons for normalization is that it allows for less redundancy in the data and it will save space. So as we go through steps of normalization, as I'm going to explain briefly, the data will become less redundant. And it also helps to eliminate some data anomalies, which would refer to the deletion, insertion, and update anomalies, which means once we have these tables in their most lean and normalized form, there's less likelihood of data being deleted or updated or inserted by mistake. We typically go through 3 steps of normalization, which we call the first, second, and third normal form. But there are other forms of normalization. It will go up higher, the fourth normal form, fifth normal form. But the third normal form is the most common form you might see in the business. And it's a cumulative format. So we start with the first normal form and going up. Alright, so let me explain these steps very briefly. The first normal form refers to the steps where we try to see if there's any repetitive attribute in our table. So we look at our table. For instance, if we look at this table, we have a student file, but we have course information that are being repeated. Let's say we want to see what courses each student takes. So we have one table. Imagine this is in an Excel format, and then we have course number 1, information about that, course number 2, information about that, and that goes on. And that information becomes repeated. And that's a good candidate for normalization. So when we see that information repeating groups, that's a violation of the first normal form. So the first thing we're going to do is that we build a new entity. We move all the repeating attributes to this new entity. So anything that was repetitive. And then we find we identify a primary key for that attribute. In this example, we're talking about course. So it's course ID. And finally, we identify any relationship that the new table has with the original entity. So in this example, a student was taking multiple courses, so one too many. So once all of these are removed, we have the first normal form. And then we move to the second normal form. And the key question you need to answer is that we look at all the non-key attributes, and we want to have all these non-key attributes being dependent on the primary key of that entity. Again, go back to the example that we have. We have a student table. We have information about student. We have information about student and course in the course registration or student course table. And we see that some of the non-key attributes, for instance, course information, course name, course major, are not related to the whole key, which is a student number and also course ID in that table. So some of those elements are not related to that. And that's a violation of the second normal form. And now we can reduce it by again taking those attributes that are not dependent to the whole primary key and take it out, build a new entity, and then use the dependent attributes as the new key, or determine one key for that. So in this example, we had a student number and course ID. That's fine. All the other attributes can still be there, but any information that's related to the course will be moved to the new entity. And again, same as before, we identified the relationship. So a course can be taken by multiple students, one to many. For the third normal form, we're looking at all the non-key attributes, and we want to see if these non-key attributes are dependent on any other non-key attribute. So now we're not looking at key attributes. We're looking at the relationship between non-key attributes and if there's any dependency that exists within them. So is there part of them, part of this information that's related to a non-key attribute. So in this example, so we had a student information, student number is key, and we see that we have department name, department location, department code. That's not related to a student number really. So what we do is that again, that's a violation of the third normal form. We build a new entity, we move that information, we set a primary key for that table, and also once that's done, we can name this relationship again. It's optional because sometimes that information may not have to be directly related. For instance, information about the department doesn't have to be related to the student. So it's actually non-identifying relationships. All right, there's also a video which I'm going to post the link for you. So if you notice, we're talking about functional dependency here. So functional dependency is the basic idea underlying normalization. So in normalization, we are focusing on identifying and normalizing our tables based on this dependency. So it's basically a constraint. It's a constraint, a limitation between two attributes or two sets of attributes. So if we see dependency, that means that there might be in the same table. So what do we call a dependency? For any relationship, for any relation R, attribute B is functionally dependent on attribute A if for every valid instance of A, the value of A uniquely determines the value of B. So basically, we can think of A identifying B. So think of it as a key, as an identifier for B. So if that exists, we're talking about functional dependency. So each normal form represents a state of relation that results from applying simple rules regarding the functional dependencies, right? We just reviewed them. The first normal form, the second normal form, and the third normal form. Again, these are examples of functional dependencies. You have if you're thinking about a book, an ISBN is an identifier for the title and for the authors. A VIN number will provide information about the make, the model, and the color of the car. Same thing for SSN, same thing for employee ID. So these are functional dependencies that we have. And why do these matter in data warehousing? Because again, we covered all this in database. So you are all familiar with ER models that we just reviewed. Source systems of data warehousing, they all use ER modeling. So ER modeling is the foundation to what's known as dimensional modeling. And we have several sessions that we're going to cover dimensional modeling later on. So once you know ER, based on ER modeling, we can do dimensional modeling. So when do we use ER? It's mostly for storing transactional data, any data that's coming from our ERP system, our customer transactions, our basically our ERP data, any data that comes from the source. And once we have that, once we need to move to analytics, data that we need to use for BI applications, we move from ER to what's known as data warehousing systems. And in order to do data warehousing, that's when we bring an ETL process. Again, we will go through ETL processes in detail in this semester. And the point is that Again, the data that exists in our transactional systems through ETL, extract, transform, and load processes, we bring them into BI applications. We talked about BI applications, any application that's used for reporting, querying, analytics, data mining. All of these are BI applications. And through the ETL processing, we check for data integrity, for data quality, and we check the access level. Again, each of these we're going to explain in detail. This is an example of how an ER model will feed a dimensional modeling. So we have our relational data. Let's say this is a product and information that's related to the product, supplier, vendor, the transactions. But we bring that into a fact table, and the fact table has a slightly different architecture, and we will talk about these star schema later on. And these tables are also called fact tables. They're not called relational databases anymore. But they have elements of our database, so they are related to each other. So that's a difference between entity and dimensional database. So again, the details of these we're going to go and cover in detail.